Hey everyone, welcome to the channel. Are you ready to build the future? Because today, we're diving deep into the world of AI agents. Forget chatbots that just spit out random text. We're talking about autonomous programs that can actually do things, make decisions, and even communicate with each other. This is agentic AI, and it's not as complicated as you might think. Think of them as digital assistants that can not just answer questions, but actually take action based on those answers. I'm talking about agents that can search the web, analyze financial data, and even write code all on their own. Sound exciting? It should. We're going from zero to hero, building these agents from the ground up. And the best part? You can do it all for free, right on your own computer. No expensive GPUs or API keys needed. Now, before we get into the code, let's talk about what makes AI agents so revolutionary. We're moving closer and closer to this concept of agentic AI. Systems that exhibit a higher level of autonomy and decision-making ability without needing constant human intervention. Think about it. Today's AI agents react to your commands. You ask a question, they find an answer. But tomorrow's agentic AIs will proactively engage in problem-solving. They will anticipate your needs, adapt to changing situations, and even learn from their mistakes. This is a huge leap forward from basic chatbots. Imagine an AI agent that not only tells you about a potential stock market crash, but automatically rebalances your portfolio to minimize risk. That's the power of agentic AI, and it's what we're building towards. The craziest part is that building these agents from scratch is becoming incredibly easy. It's like going back 10 years, when training a logistic regression model was a complex task. Now, scikit-learn makes it so simple, you can do it in a few lines of code. The same thing is happening with AI agents. New tools and libraries are abstracting away the underlying complexity, putting the power of agentic AI into the hands of anyone who wants to learn. And that's what this tutorial is all about. I'm going to show you, step by step, how to build different types of AI agents, from simple to advanced. I'll provide you with Python code that you can copy, paste, and run. I'll walk you through every line of code with comments, so you can actually understand what's going on and replicate this example. This isn't just theory. It's hands-on, practical knowledge that you can use to build your own amazing AI agents. All right. Let's get our hands dirty. The only tool you'll need is Ollama. Ollama lets you run large language models, or LLMs, locally on your computer without needing any cloud-based services. This gives you complete control over your data privacy and performance. No more worrying about sending your sensitive information to some remote server. Just download Ollama from their website. The link is in the description. Once you have Ollama installed, you can download your LLM of choice. I'm going with Alibaba's Qwen because it's both smart and lightweight. Just use the command Ollama pull Qwen 2.5 in your terminal, and Ollama will take care of the rest. Once the download is complete, you're ready to start writing code. Seriously, it's that easy. We are talking about running cutting-edge AI on your local machine. It's mind-blowing. We're talking about having the power of a cloud-based AI right on your desktop. And it's all thanks to tools like Ollama. This is truly democratizing AI. Okay, let's make sure everything is working. Open up your Python interpreter and type import Ollama. Then, let's define our LLM. LLM equals Qwen 2.5. Now, let's give it a quick test. We'll ask it a simple question. Stream equals Ollama.generate. Model equals LLM. Prompt equals what time is it? Stream equals true. Then, we'll loop through the response and print it out. For chunk in stream, print chunk response. End equals flush equals true. Now, if you're like me, you're probably thinking, okay, this is cool, but it's just a chatbot. It can't actually do anything. And you're right. By itself, the LLM is very limited. It can chat, but it can't take action. That's where tools come in. We need to give our LLM the ability to activate tools, to interact with the outside world, to actually do things. One of the most common and useful tools is the ability to search the internet. In Python, the easiest way to do this is with DuckDuckGo. You can install it with pip install DuckDuckGo search equals 6.3.5. Now, we need to create a function that our LLM can use to access this tool. We'll use the LangChain wrapper for DuckDuckGo. So, install it with pip install LangChain community equals 0.3.17. Now, here's the key part. With Ollama, in order to use a tool, the function must be described in a dictionary. This dictionary tells Ollama what the tool does, what its name is, and what parameters it needs. It's like giving the LLM a blueprint for how to use the tool. It's a really elegant way to integrate external capabilities. Here's the code. From langchain_community.tools import DuckDuckGo search results. Def search_web query str-str Return DuckDuckGo search results. Backend equals news.run query. Make sure the backend is set to news so we don't get overloaded with information. We'll then define the dictionary for the tool. This is where we tell Alma what the tool does and how to use it. It's like giving the LLM a blueprint for how to use the tool. Internet searches can be very broad, and I want to give the agent the option to be more precise. Let's say I'm planning to use this agent to learn about financial updates, so I can give it a specific tool for that topic, like searching only a finance website instead of the whole web. This is where things get interesting, because we can customize our agent to be an expert in a specific domain. We're not just building a general-purpose chatbot, we're building a specialized AI that can provide targeted information about financial updates. It's all about giving our agent the right tools for the job. This makes it easier for the agent to focus on the information that is relevant to the user's needs. So, let's create a function to search Yahoo Finance. Def search_yf, query, str-str, engine equals DuckDuckGo search results, backend equals news, return engine.run, f site, finance.yahoo.com query. Now, we can test it with search_yf, query equals NVIDIA. See how easy that is? We've created a custom tool that can search a specific website for financial information. This is the power of AI agents. In my opinion, the most basic agent should at least be able to choose between one or two tools and re-elaborate the output of the action to give the user a proper and concise answer. What does this mean? It means that our agent needs to be able to decide when to use a tool, and then take the results of that tool and turn it into a coherent answer for the user. It's not enough to just search the web. Our agent needs to understand the information and present it in a way that's easy to understand. This is where the real intelligence comes in. So, first, you need to write a prompt to describe the agent's purpose. The more detailed, the better. This is the first message in the chat history with the LLM. This is where you give your agent its personality and its goals. It's like giving it a mission statement, and that mission statement will guide its actions. Here's an example prompt. Prompt equals, you are an assistant with access to tools. You must decide when to use tools to answer user message. Then, we'll create a list of messages to store the chat history. Messages equals role: system, content, prompt. This is how the LLM remembers what you've said, so it can provide relevant context. Now, we need to create a loop that allows the user to interact with the agent. This loop will take the user's input, pass it to the LLM, and then either return a text response or activate a tool. It's like a conversation with the AI. This will keep the chat with the AI alive, so I will use a loop that starts with user's input and then the agent is invoked to respond, which can be a text from the LLM or the activation of a tool. This is where the magic happens. This is where the agent comes to life. Let's create the while true loop that handles user input, checks for exit conditions, and appends the input to the messages. This loop will be the heart of our agent. Try to anticipate edge cases, like an empty input. This will make our agent more robust. If the user enters quit, the loop will break. Here's the crucial part. If the model wants to use a tool, the appropriate function needs to be run with the input parameters suggested by the LLM in its response object. So our code needs to get that information and run the tool function. The LLM will tell us which tool to use and what inputs to provide, and our code will take care of the rest. It's like being the conductor of an AI orchestra. You don't have to play every instrument yourself, but you need to know which instrument to call upon and when. So, we extract the tool name and inputs from the LLM's response. Then, we find the corresponding function in our dict_tools dictionary. If we find the function, we print a message to the console indicating which tool is being called, and then we execute the function with the provided inputs. Finally, we take the output of the tool and summarize it to answer the user's question. This is where the LLM uses its natural language processing abilities to turn the raw data from the tool into a coherent answer. Okay. Let's take things to the next level. LLMs know how to code by being exposed to a large corpus of both code and natural language text. They learn patterns, syntax, and semantics of programming languages. The model learns the relationships between different parts of the code by predicting the next token in a sequence. In short, LLMs can generate Python code, but can't execute it. Agents can. And that's what we're going to do. Create an agent that can execute code. This is where things get really interesting. We're not just talking about answering questions anymore. We're talking about automating complex tasks, analyzing data, and even creating new programs. This is the power of AI agents, and it's what we're going to unlock today. I shall prepare a tool allowing the agent to execute code. In Python, you can easily create a shell to run code as a string with the native command exec. This is a powerful tool, but it's also dangerous. You need to be very careful about the code you're executing because it could potentially harm your system. That's why we're going to wrap the exec command in a try except block to catch any errors that might occur. This will prevent our agent from crashing if it encounters a problem. Here's the code. Import IO, import context_lib, def code_exec, code, str-str, output equals io.string io, with context_lib at redirect_stout, output try, exec, code, accept exception as e, print f, error, e, return output.getValue. This function takes a string of code as input, executes it, and then returns the output. We've created a safe and reliable way to execute code within our agent. This is a huge step forward. Just like before, I will write a prompt, but this time, at the beginning of the chat loop, I will ask the user to provide a file path. Since coding tasks can be a little trickier for LLMs, I am going to add also memory reinforcement. By default, during one session, there isn't a true long-term memory. LLMs have access to the chat history, so they can remember information temporarily and track the context and instructions you've given earlier in the conversation. However, memory doesn't always work as expected, especially if the LLM is small. Therefore, a good practice is to reinforce the model's memory by adding periodic reminders in the chat history. This will help the LLM stay on track and avoid making mistakes. It's like giving it a cheat sheet to refer to. It's particularly useful when working with coding tasks, where the LLM needs to remember the context of the code it's generating. Here's how we do it. We create a prompt, and the user provides a file path. Then, we define a memory variable that stores information about the data frame, which in this case is df. This is the information that we want the LLM to remember throughout the session. Then, in the chat loop, we prepend the memory variable to the user's input so that the LLM always has access to this information. This is a simple but effective way to reinforce the model's memory and improve its performance. Please note that the default memory length in Ollama is 2048 characters. If your machine can handle it, you can increase it by changing the number when the LLM is invoked. You can adjust the number_ctx parameter to control the amount of memory the LLM has. If you have a powerful machine, you can increase this number to improve the LLM's performance. In this use case, the output of the agent is mostly code and data, so I don't want the LLM to re-elaborate the responses. I want the raw output of the code execution without any further processing. So, we modify the code to simply print the output of the tool without summarizing it or adding any additional text. This gives us a clear and concise view of the results. This is especially useful for debugging and analyzing data. By default, the LLM will try to interpret the results and provide a natural language summary. But in this case, we want the raw data, so we need to disable this feature. So there you have it. We've covered the foundational steps of creating agents from scratch using only Ollama. You've learned how to set up Ollama, how to create tools, how to write prompts, and how to build a chat loop. You are now equipped to start developing your own agents for different use cases. This is just the beginning. The possibilities are endless. You can build agents for automating tasks, analyzing data, creating content, and much more. The only limit is your imagination. Stay tuned for part 2, where we will dive deeper into more advanced examples. We'll explore more complex tools, more sophisticated prompts, and more advanced techniques for building AI agents. But for now, I encourage you to experiment with the code we've covered today. Try building your own agents and see what you can create. The full code for this article is on GitHub. Feel free to contact me for questions and feedback or just to share your interesting projects. Let's connect and build the future together.